Hello everyone, welcome back to the TechART Learning Hub. I'm Preeti Bodeti, and as in our previous session, we explored an overview of Hugging Face and its powerful libraries. As promised, today we'll be working on the hands-on implementation of the Hugging Face Pipeline API. So let's get started. Pipelines simplify complex machine learning tasks by making it easy to use the pre-trained models for natural language processing, image generation, and audio generation with just few lines of code. How simple it is to use the pre-trained models so as to accomplish our desired task. Now let's take a look at few of the key tasks the pipeline API supports. Sentiment analysis. It determines if a text is positive, negative, or neutral. Named entity recognition. It identifies names, locations, and organizations in a sentence. Question answering. It finds answers from a given text. Text summarization. It shortens long paragraphs into shorter ones while retaining key details. Translation. It converts text from one language to another. Zero-shot classification. It classifies text into categories without prior training. Text generation. It generates text from a given prompt. Image generation. It creates images from a given text paragraph. Text to speech. It converts text into spoken audio. So these are the key tasks the pipeline API supports. So let's go into these tasks and perform some implementation and check how these tasks work. These powerful capabilities or tasks allow us to explore a wide range of AI-driven functionalities with minimal effort. Now let's take a closer look at these functions into action. We'll perform sentiment analysis, generate text, extract named entities, answer questions from text, generate images, and also convert text to speech. To implement these, we'll be using Google Colab, a cloud-based notebook where we can run the Python code effortlessly without any setup. It provides access to GPU acceleration, making it ideal for experimenting with Hugging Face models. So now I just want to show you all the Hugging Face website, and this is where we are going to create the access token for the Hugging Face so that we can connect with its models via the pipelines. So this is the Hugging Face. You have to type huggingface.co and you land into this page, and you have to create a profile in this, and I have created one. So under your profile, just go to the settings. In settings, if you see on left side, you have access tokens. So click on that and you will be having a button called create new token. So click on this and create an access token for yourself. I have one, so do it now. And once the access token is created, just go to the Google Colab. So I'll say Google Colab. Go to the Google Colab and create a notebook for pipelines. So I'm just going to my required Google account and creating a new notebook. So this is the pipelines notebook in Google Colab, and I have also now in here you have to add an access token that you have created in the Hugging Face. So this is what I have added, HF token, and I have given the credentials for the password. So what you have to do now is, once you have added, just click on add new secret key, give a name for that, and then enter your password. This is all what you have to do. After that, this Google Colab notebook, so as to access these credentials, it has to be activated. So if you can see here, there is a toggle right here. Just click on that and close it. So it means that we have activated the access token under this notebook, which we can now use it to perform our tasks. So this is all the setup. Next we will work on the implementation. Now we need to set up the runtime. So here under this, just click on it and say change runtime, and prefer for the runtime type to be Python 3 and the hardware accelerator to be T4 GPU, which is an NVIDIA processor. It is very powerful, where it is capable of handling large models efficiently. So click on that, click save, and then connect to it. I have already did connection, you all just do that. So once the connection has been established, just move on to installing the necessary libraries. So first, to always run the shell commands in our notebook like Jupyter or Google Colab, we need to start it with exclamatory. So exclamatory pip install -q is the quiet mode, where it suppresses the installation processes when executed. So -q is for that. Then we'll move on with transformers, diffusers, and datasets. Transformer is a toolkit that helps in connecting with the models, and diffusers is to perform tasks with images, and datasets is to have access with the Hugging Face datasets. So that is all. We'll just click run and we'll see the installation. Yeah, it is successful. Then we will move on to the import statements. So the first one is we will import torch, and then we will import google.colab import user data. I will just explain you all what these import statements are. And next we will import from Hugging Face Hub, import the login, so that we'll have login to the Hugging Face. And then from transformers, import pipeline, from diffusers, import diffusion pipeline, from datasets, import load dataset, and import sound file as SF. From python.display, import audio. These are the import statements. Import torch is to interact with the PyTorch models. The sound file is to interact with the audio files. And then the google.colab import user data is to load the access tokens that we have mentioned. And the Hugging Face hub is imports the login, so that we can log in with our Hugging Face. And import pipelines is to work with the tasks using the models. And the import diffusion pipeline is to work with images. And import audio is to display the audio file. And the data sets is to work with and access the Hugging Face data sets. So let's run the import statement, and now we will work with loading the Hugging Face token, and we will log into the Hugging Face. So I'll say hf token is equal to user data dot get of the hf token that we have given as a name in our credentials. So token, and then we will log into the Hugging Face using this token, hf token. So let's see by running that. Yeah, so we have successfully logged into the Hugging Face. Now we will use the pipeline, and we will connect to the model, and then we'll perform the specific tasks. Now let's start with our first task, that is sentiment analysis. So I would give as sentiment analysis. So let's give as sentiment analysis is equal to a pipeline function where I'm going to mention it as sentiment analysis, and I'm going to give the device is equal to CUDA. I will explain your statement by statement, and then we are going to give result is equal to sentiment analysis, and I'm going to give as the phone I bought was fantastic. And I would say print the result. So let's run the code. So before that, I will say here we have given a variable SA, that is sentiment analysis, and we have run a pipeline function where we have mentioned sentiment analysis. This will tell the pipeline, hey pipeline, please load a model that is efficient in recognizing sentiments beneath any statement given. So here's how it's going to do, and the device additional argument we have mentioned is CUDA. This CUDA is a device that helps the loaded model to run over the GPU. And we have mentioned the result variable where it is going to hold the result, that is the sentiment, when this given input is given, like the phone I bought was fantastic. So based upon this given input, the pipeline is going to load the respective model, and that model is going to process this input and give a proper sentiment that is beneath this text. So let's run it and see what the result is going to be. So yeah, here it has labeled as positive, so it means that it is a positive sentiment, because I have said it was like fantastic. So let's see, like the phone I bought was not doing great. So if I say not doing great, and see how it's going to react as well. So see, it has labeled it as negative. So the models can recognize what kind of sentiments a particular statement can hold. So how good is that, right? It's so nice. So this is the first task, that is sentiment analysis, that we are working on using the pipelines. It's so easy to interact with a model with just few lines of code. Just look at that, like pipelines have really made the coding effortless, like truly to say. Next we will move on is the next one is named entity recognition. So I will say named entity recognition. I'm like truly not able to type. Named entity recognition. So I will say NER is equal to, we load the pipeline function with the named entity recognition, and the device is always going to be the CUDA. And let's say result is equal to named entity recognition, and let's give as Albert Einstein was awarded the Nobel Prize in physics in 1921 for his work on photoelectric effect. So I have given this, and let's see what the result is going to be. So it is going to recognize the tokens that belong to a particular entity. It could be a name, it could be a person, it could be an organization, or it could be anything else. So let's run it and see what tokens it's going to pick and which entity do they belong. So the first entity is person, and if you see the word, it's and Einstein. I just forgot to mention an additional argument. I will just do that quick modification, but just first let's see the output. So here is one person, that is Albert, and there is another person again with the word Einstein, and the rest is the miscellaneous. It's the word in, and then it's the word physics. Okay, so if you can see, they are if you can see, Albert and Einstein are both the person name, but they are given in separate objects. So what is, now I'm going to give an additional argument as grouped entities is equal to true. Okay, now again let's run the code and see what the output is going to be. If you can see, now it has grouped Albert and Einstein into a single entity, and they belong to one group, that is person. And the next is the miscellaneous, and those words are Nobel Prize in physics. So these words belong to the entity miscellaneous. So this is how that additional argument grouped entities bring into an effect. And yeah, this is all the implementation about the named entity recognition. It recognizes the tokens and put them into their respective entities. Yeah. Next, moving on, is the question answering task. So let's start that implementation. Question answering task. So let's comment this, and this is going to answer the question based on the context given, but not on the pre-trained data. So let's say as QA is equal to load the pipeline function with the question answering task in S double. Yeah, and then let's give the device is equal to CUDA. Now let's give the result is equal to QA, and let's give a question. So the question is, where is the Eiffel Tower located? So this is the question, and then we are going to give the context. So we are going to mention as Eiffel Tower was located in Paris. Yeah, so this is the context. Sorry, is located in Paris. So this is the context, and based on this context, it's going to answer for the mentioned question. So I'm again wrong with the pipeline term. So yeah. So let's display the result. And if I run this code, and if you can see, it has mentioned as Paris. So this answer has come from the context which we have given, but not on the pre-trained data. So this is all about the question answering. Next we will move on to the translation process, where it converts one language to another, and then we'll work on the other tasks as well. Okay, so now we will start the translation implementation. So I'll comment this as translation, and now we'll give a variable as tr is equal to, we load the pipeline function, and let's mention as translation, and translate it from the language English to Hindi. And then let's mention the device is equal to CUDA. And now we'll give the result is equal to tr of, we'll give an input. We will say the Taj Mahal is one of the most beautiful monuments in the world. So let's see what the output is going to be. So let's display the result. The result I'm going to give as an translation text. Before I used to give result, and now I'm giving it as result of 0, because this result will always display a list of dictionaries. So I want the first dictionary with the key name as translation text, because we want only just that value where we have the translation sentence. So I'm just going to see the result, and we have some error. So let's see what the error is. The task does not provide any default models for option English to Hindi. Oh, okay. So let's try something different maybe. So I have given as English to French. I am not used to what French is. So if anyone who knows French, then please see whether the output that was generated is correct or not. Because it's not supporting the language I know, that is Hindi. So yeah, if you see, it's like late Taj Mahal, as I couldn't pronounce properly. But yeah, I guess it is similar to the text given. I hope the people who knows French will know the accurate result that was given. And yeah, this is all about the translation. Next we will move on is the text summarization. So it's going to give the summary of the text, which includes the key details also. So I'm just going to give as the comment with text summarization. So we'll see as summarizer is equal to pipeline, and we will give it as summarization, and then we are going to give the device is equal to CUDA. Next we will mention the text which we want to give the summarization for. I have the text already, so I'm just going to copy paste it. Okay, so let's paste this. Okay, for the multi-line, yeah. So this is the text, and now we are going to give the result is equal to, we are going to give the summarizer with text, comma, maximum length is equal to some 50, and then minimum length is equal to 25, and then do sample is equal to true. Yeah. So now let's print the result of 0, and then we are going to give as summary text. So let's see what the result is going to be. So yeah, it has given the summary. Hugging Face Transformers library is an incredibly versatile tool for NLP. It allows users to perform a wide range of tasks such as text classification, named entity recognition, and question answering. We have this big entire text, and it has briefly summarized into the most important terms about the Hugging Face Transformers. How beautiful is that, right? So this is all about the text summarization, and next we will move on to the other tasks. So the next task is the text generation. So let's start the implementation. So we'll say text generation. So we will give as generator is equal to pipeline of text generation, and we'll give device is equal to CUDA. So here we are going to give the result is equal to generator of I would say the future of artificial intelligence is. So let's see what it is going to give. So I'm going to print the result 0 with generated text. So let's run this and see what the output is going to be. So yeah, we have got the output. The future of artificial intelligence is uncertain. It does not mean we are doomed to enter a new era of AI. Professor Michael Dube said, with the help from several international partners and some real progress as. So it has given it as the future of artificial intelligence is uncertain. So this is the result of the text generation. Next, moving on is we will work on the zero-shot classification, where it classifies the text into different categories without any prior training. So we'll say zero-shot classification. So it classifies the text into categories without any prior training. So we will say as classifier is equal to pipeline with zero shot classification and device is equal to CUDA. Next we will give the result is equal to classifier, let's say hugging faces transformer library is too good when interacting with models. So I have given this, and we should also mention as candidate labels is equal to, it could be anything, it could be technology, or it could be sports, it could be what can we say, it could be sports, it could be politics. Okay, I have given some categories because there is no prior training. So we are going to print the result and see what it's going to be. Okay, here I have mentioned 0. Yeah, let's run it again and see the result. So it's going to give a score for each of the category, but the highest probability we'll see which category it has. So let's check the output. Yeah, we have got the result. So the sequence is hugging faces transformer library is too good when interacting with models. So the labels here we mentioned are technology, sports and politics, and the highest probability it has is 0.9, which is technology, because hugging face belongs to the technology category, and the other for the sports and politics it has 0.0.1 and 0.0.1. So it has the least probability, and the maximum probability is obviously the technology. So it has guessed it right. So this is all about the zero shot classification. Next we will move on to the two more tasks, that is image generation and text to speech generation. So now we will be working on the image generation. So I have loaded the model that is responsible for generating the image. So this loads the pre-trained model from the Hugging Face hub. So I have mentioned Stability AI Stable Diffusion 2. It specifies the model you are using, and the torch D type is equal to torch dot float 16. It is like it uses the half precision floating point 16 bit for faster computation and less memory usage on the GPU. And then the use safe tensors is equal to true. This flag ensures the model weights are loaded in safe format, providing better security. And the variant is equal to FP16. The model is optimized for FP16 precision, which means that it's designed to run faster on GPUs that support it. So dot 2 is equal to CUDA is like it's going to run this loaded model over the GPU. So now let's start giving the prompt and then generate the image using this loaded model. So I would give as text is equal to, I would say Taj Mahal, I would say that, and then I'm going to give an image is equal to image generator, where I give the prompt is equal to text, and then dot images of 0. I want the first highest probability image, and then let's give image. So let's see and run the code. Yeah, we have got the image of the Taj Mahal, and see how beautiful it is to watch it. So this is all about the image generation. So I have mentioned the text, like the prompt, as the Taj Mahal, so it has given me the image of that. For example, if I would say as an Eiffel Tower, so I would say Eiffel Tower. So let's see and let's run it and see what we are going to get. So yeah, we've got the image of an Eiffel Tower. This is how it looks. So this is all about the image generation task via the pipeline. So the last task which we are going to implement is text to speech. I have mentioned the code already. So here I have given synthesizer is equal to the pipeline function, where I have mentioned text to speech, and I also mentioned Microsoft with the model speechify underscore TTS, that is text to speech, and the device CUDA. So the pipeline uses the Hugging Face transformers library to load the necessary model and processing. And the Microsoft speechify, it specifies the model that you are using, which is Microsoft speechify text to speech model. And the CUDA device is to load the desired model and run them over GPUs. And embeddings underscore dataset is equal to load dataset with I have given a particular dataset, and I have given another parameter as split is equal to validation. So this is like this loads a dataset which is called the CMU Arctic X vectors from the Hugging Face datasets library. The dataset contains the speaker embeddings, that is the voice features, and is being loaded from the validation split, okay, which I have mentioned just here. So which is often used for model evaluation. And then we have given the speaker embedding is equal to torch.tensor embeddings underscore dataset of, we have given a parameter index from the vector x from the dataset x vector. So what does that mean is this extracts the speaker embedding for a specific index which we have mentioned 7306 from what the dataset X vector. So the X vector is a vector representation of the speaker's voice, and we have also mentioned dot unsqueeze of 0, which means like it adds a new dimension to the tensor which is needed to input the embedding into the model. So this is about the speaker embedding. Next we are going to get the speech. So speech is equal to the synthesizer which we have mentioned earlier with the loaded model, and we have given a text as welcome to the world of artificial intelligence, and an additional parameter as forward params where I have mentioned the speaker embedding. So this line generates the speech from the text hi, that is welcome to the world of artificial intelligence, and the forward params parameter passes the speaker embedding to the model. So the speech is generated in the voice represented by that embedding we have mentioned, that is speaker embedding. So then we have imported the sound file earlier, right? So we are going to write as sf.write speech.wav and speech of that audio, and then sample rate is equal to speech of the sampling rate. So this saves the generated speech audio with the .wav file, that is what we have mentioned, and it uses the sound file library sf to write the generated audio into a file which is named as speech.wav, okay, with the correct sampling rate. So then we are using the audio of speech.wav that was generated. So this will play back the generated speech using the Python's audio class we have imported, right, that one, and it will display an audio player in this Jupyter notebook. So let's see whether we are going to get the audio generated or not. So let me run it. So we have
Welcome to the world of artificial intelligence.
So you can see, right? I'll play it again.
Welcome to the world of artificial intelligence.
Yeah. This is how we can generate the audio from the given text. So the entire thing is like we have to load the model which is responsible for converting the text into speech and what kind of speaker embeddings we want. So I have just loaded a data set, I have mentioned it, and there from that data set I have mentioned some random index, and I have pulled the required speaker, and I have regulated with the dimensions. So then I have given the text where it converts that text into speech with the adjusted speaker embedding, like whatever speaker we want, and then we have used the sound file where it converts that generated speech with an extension of .wav, and then we are going to play that audio. So that's a wrap on our exploration of Hugging Face pipelines. In the upcoming tutorials, we'll shift focus and dive into tokenizers, a crucial part of working with models. We look at detailed implementation on how to effectively use them. Thank you for watching. If you found this session helpful, please like, share and subscribe for exciting content. Also be sure to check out the TechART deals for creative products. See you in the next video.